So two equations with two unknowns, substitution or elimination. So I want to do substitution here. I can see I can solve for x in one of these. So x is 2y plus 1 if I just kick that over. Now that I have an equation for x, I can substitute that into the other equation. And so replace the x with the 2y plus 1 squared minus y squared equals 16. Now I have an equation just with one variable which I can solve. I need to do 2y plus 1 squared, so don't forget that means that it's 2y plus 1 times itself, so I'm going to need to FOIL that out. So this is 4y squared plus 2y plus another 2y is 4y plus 1 minus y squared is 16. Whenever you end up with an equation with a power that's higher than 1, your goal is to set it equal to 0 and factor it, or try to factor it. So you have 4y squared minus y squared, and you can combine those, that's 3y squared plus 4y. And again, we want to set it equal to 0, so I'm going to swing this 16 over, subtract 16, minus 15 is 0. Now you attempt to factor this thing. You first look for a greatest common factor. Unfortunately, there is none. I want to do trash method because I feel like it. I'm looking for numbers that multiply to make negative 45 that add to 4. So maybe a 9 and a negative 5. So the way trash method works is I write that 3y squared. Since it's a 3y squared, I write 3y and 3y there for now. Those numbers I find, plus 9 minus 5, and then I trash whatever common factors I have. So I can trash, these are both divisible by 3, so trash that. Y plus 3, 3y minus 5 equals 0. So if you don't like trash method, you don't have to do it. However you factor that, you can use an Xbox. You can use an Xbox, you can use a star, you can use guess and check. However you want to get there, get there. And now the reason why we factor, the whole reason we do this is because we know that if this times this equals 0, then one of these factors must be 0. So either y plus 3 is 0 or 3y minus 5 is 0. So this means y is negative 3, 3y equals 5, so y is 5/3. A lot of times you see it straight from there, that's fine. So long as you get there, we're good. And, alright, so we're not done yet though, because remember where we started with two unknowns. I know y, but I don't know x yet.
Yeah.
So what I gotta do now is
plug it back in.
Plug it back in, exactly. I've got this lovely equation for x. So I know that when y is negative 3, x is going to be 2 times negative 3 plus 1. So that's negative 6 plus 1 is negative 5. So that's one ordered pair. X is negative 5 when y is negative 3. There's one answer. And then, oh god, I have to plug in 5/3? That sucks. So I know when y is 5/3, then x is going to be 2 times 5/3 plus 1. I'm going to write 1 as 3/3. So this is 10/3 plus 3/3 is 13/3. And so now that's my next ordered pair. When x is 13/3, I know that y is 5/3, and that's my second answer. So those two answers will satisfy both of those equations. You can check it, right? You can plug in negative 5 and 3, 5 squared plus minus 3 squared is 16, scared myself for a second, and negative 5 minus a minus 3, so that's negative 5 plus 6 is 1. Totally checks out. You can check it for that one too, but I don't feel like it, so it's good.